really excited for today's event. This is our third Miner Show and Tell, which is very exciting. So pop in the chat, let us know where you are tuning in from, and we'll get underway very shortly. Hi, Lawrence from Canada. Very warm welcome. We've got some of your fellow Canadians presenting today. Hi, Edison. Edison is in China. Very awesome. Emily from Washington, DC. Always good. Welcome from Austin, Texas. Wonderful. Very exciting. Okay, let's get cracking. Thank you everyone for joining us for the third Filecoin Miner Show and Tell. This week we'll be hearing from some of our top miners in North America and Europe. Tonight's event is part of a series of events throughout Space Race, which is our incentivized testnet competition. You can see what's coming up on spacerace.filecoin.io and catch up on anything you've missed on our YouTube channel, which is linked below. We've got a fabulous lineup of speakers today, so let's get started. Our first miner to present is Benjamin, who was also named a Filecoin Community Champion in last week's Space Race report. Welcome, Benjamin.
Thank you very much. I'll just get my video on here. So should I just get started?
Yep, go for it whenever you're ready.
Awesome. Alrighty. So hopefully you should be able to see my screen. All good?
Yep, perfect.
Alrighty. Yeah, so I guess I represent some of these smaller sized miners. So I think last time we saw some of the bigger ones. I guess what I wanted to show and tell about today is how to mine efficiently on a smaller mining setup, but also the terms that you run on an unmodified Lotus. So basically, I haven't not been doing any custom coding, any tweaks, anything. I basically just rely on whatever is released and hope for the best from there. That also means that the setup that I'm running is kind of tweaked against meeting least amounts of problems with unmodified Lotus. So just to dive right into it. My own setup does not look exactly like this, but this is more like a representation of what it basically could look like. So what I've done for these smaller setups is basically try to keep each of the individual processes or jobs as separate as possible. So as you see here on the top, I have my miner, which holds the daemon, the miner, and also the storage. So that's the one goes on top. Then I have a dedicated worker only doing PC1. I have a dedicated worker only doing PC2. And then I have the last one doing, that's so mainly the C2 job. All connected with the 10 gig or better. But this is kind of the base setup for having an environment that mines pretty efficient. So I know that there are a lot of small miners partly complaining about having a single miner setup, partly saying it works fine. There are also miners having multiple single miner setups. I found that this setup is probably one of the least problematic setups to have. Also because I have pretty good control over the individual processes. So making sure my Lotus daemon and the miner is not clocking up because it's doing other stuff that it's not supposed to. Of course, it is possible to run it as one, but I just find it much easier to try to separate things. So at least this is kind of the base for what it looks like. I also put some prices on here just to give you an idea about what is the size of this. So you see it's a little bit, I think, over 16,000. There are also some parts missing. What I've tried to focus on here is that I have mainly been using AMD EPYC CPUs. I like to use the EPYCs because you get the ECC memory, and in general, it just feels like a more stable platform. So I would say that I have seen very few like hardware-related or compute-related errors on this setup. And I guess in the end, that's also pretty nice that you don't have that additional factor of what if you have like a bit corruption and stuff like that on top of it. So, you know, trying to minimize that. The other part is that it's not like AMD EPYC CPUs are really, you know, super expensive. So it's still doable. Now the setup here is basically, again, taking into account that you have the different individual workers. What you see is that actually the miner in itself is pretty beefed up. And well, we saw on the emulated attack here this morning that is actually a good idea, because even though that you might have a miner that can follow the chain, then it gets really stressed when trying to do this under attack and so on. So this, at least for my setup, has been working pretty well. That said, you know, you could joke that, so how well has this been going on? Because how much power have you left? And I think the answer is I do not have much, but I guess I will regain that sooner or later. But I don't think that I can, you know, explain that to be because of this setup. So another thing that I wanted to point out is that the setup I chose here for the PC1, which is a lot of people is talking about the PC1 worker, like that's the only really important thing. And I'm pretty sure that, yeah, it can be difficult to make work, but I actually find it easy just to have like a single EPYC here with like half a terabyte of memory, and then about 6 terabytes of NVMe disk in RAID 0. So you want as much I/O as possible. So that's one thing. And the other thing is that when you have the 6 terabyte, you could ask, you know, why do you need that much? If it's only 600 gigabytes per sector, you can have 10 sectors on there. Why do you need that much? You're not going to have 10 sectors in parallel here. So the thing is that that it takes some time before this storage is released again. So you basically need to make sure that you have enough storage here, that you can keep on patching new sectors, but at the same time keep that until they have been committed to the network. So that's why there is some additional on it. I do not have time to run through this in detail, but the thing is that I can share this afterwards if somebody wants some inspiration. Basically, I have 10 gigabit network on all of them, but I think that most of you sooner or later knows that it's basically between PC1 and PC2 that you have this big bottleneck. You need to move those 600 gigabytes of files. Yeah, so let's just continue here. This is actually the one that I wanted to talk most about because I'm pretty sure that this looks pretty complex, but this is actually the key to efficient mining on a setup like this. Basically, you have every hour, so you have from 0 hour to 6 hour here. You have as just about every hour, you do an add piece or fetch a new sector. So you have a process running there every hour. You have this kind of rolling setup where you have about 6 sectors doing PC1 in parallel. So the miner is able to do about 7, but it does not really make sense in this setup. So that's why I put it to 6, because it also has to balance. And that's kind of the key point here, is that you need to make things balance. So while you have the 6 sectors here, you would see that you also have 6 sectors going down here. So you have 6 sectors working in PC2. You have 6 sectors on wait seat. Actually, you can have a bit more because we don't care about them when they're there. But you can also have about 6 sectors completing C2, and then they go into proving. So the point is that if you do this and really tweak it, and in reality, I might do something like 5 to 6. But if you really tweak this, then basically you can have this system spitting out a new 32 gigabyte sector every hour. So that actually is not, that's a lot more than 500 gigabytes per day. It's actually more close to 770. But the thing is that in reality, we have all these deal errors, syncing the chain, Lotus updates, everything. And as I said here, it takes about half a day to gain momentum because you don't want to pitch all 6 sectors in once. You want to have it rolling like this. And that is also to optimize how much storage you're using. So I can definitely share this one. And I do think that it's a little bit complex to look at. But if you see the green line here, you basically see that at a point in time, you have 6 running in parallel here. You have PC2 running. You have something in wait seat, and you have a C2 running. So that's the idea. And just to give you an idea about what it looks like in Lotus, you have not that many here, but you basically have your C2 job running, you have your PC2 job running, you have a bunch of C1s running, and you will see a lot of stuff over here because you have wait deals, you have something that goes packing, you have wait seat, you have something going to PC2, and so on. So you want to see that it's got like widely spread all over the place here. So that's kind of the idea to make this work. So this is just some pictures from my basement, and I already showed this to a few other miners, which find it's pretty fun. But the thing is that this is my basement where I just have this stuff thrown around. This is my miner. This is actually my PC1, which is a HPE server. Basically using non-HP memory, non-HP NVMe disks, just using it like a regular computer, and it works perfectly. Then we have the PC2 and the C2 up here. So over here, that's my normal networking rack where I have the firewall, I have my switch, and then because this is actually a deep learning setup, it's actually have some pretty powerful switches going on here. So this is actually one of these kind of rocky setup where you can do really fast file transfer over almost a lossless connection. So that also helps a lot. Now, the other thing that I wanted to point out here is that we also have some, I basically use liquid cooling to cool the computers. So my basement is only about 25 degrees, but I basically pump this over in my floor heating. So I remove about 2,000 watts here at about 40 degrees. And it is pumped with, this is glycol, and it's pumped over into the dirty water going into my heating system in the house. So that's also a way to utilize the energy coming out of this. So that's basically what's heating my house right now. And this is just a look inside one of these when you have built it all up. So another thing that this is actually the last thing I just wanted to point out is I also have this other one called the GoGo Intel Miner. And the thing is, I wanted to see how crappy hardware I can actually run this on. So the only thing where I chickened out is on the miner itself, where you see it has a pretty beefy Xeon Gold and a 2080 Ti. So that's pretty awesome to do that part. But the thing is that I really wanted to do some really low-key stuff for the other things. So my PC2 worker here is a super old Intel Xeon, which is totally beat up. But it can still do a PC2 in a little bit over an hour. And then this one is I'm really proud of. That's also a totally old, totally underpowered Xeon. And it does not have much, but still it can do it in 2.5 hours. And what I did was basically just put 2 in to do C2. So now I have 1 to do PC2, and I have 2 to do the C2. And I end up having about a sector coming out a little bit over every hour. So this is really, the kind of basement stuff that, some miners would work. And I think that it's really interesting to see how low can you actually go, because it comes down to that the PC1, which is the one that you saw before, that's the one doing PC1, but that is basically the only one that really needs the AMD. And for the rest of it, you can be a lot more creative in how you set it up. So I guess that was pretty much what I had to say. So it might be there are some questions here.
Yeah, we've got one question here in the chat, Benjamin. Have you, from Edison, he's asked, have you tried using Worker to do P1 plus P2?
P1 plus P2. Yeah, okay, so PC1, PC2. Yeah, so what happened, and I don't know because I haven't tried it lately, but what happened when we did it with the earlier ones in calibration, where I kind of designed this, was that basically it only does PC1. So when you have a new sector coming in, so basically right now, if you set your weight for deals to like every hour, which mine is set at, then basically it would just keep on pushing in new PC1s, and it wouldn't do a PC2. Now, obviously, you are able to do this on a single miner setup, so you can tweak this. But I find it really hard to to mix these things. What you could do was also to have two workers on the same machine. But then again, it gets a bit more complicated, and I think that this, of course, you use a little bit more hardware in here, but as the hardware in itself is not really that expensive, I think that you just get more throughput from just having things isolated.
Yeah, that makes sense. Thank you so much, Benjamin. Like, first of all, I'm just completely blown away by your mining setup heating your house.
Yeah, it's a little bit ridiculous.
How did you even like go there? Were you just like, oh, maybe this will work? Like, I don't understand. I'm trying to understand how you like come to the place where you're like, oh, maybe this can connect to this. So yeah, amazing.
Yeah, no. So for my work, I work with high performance computing, but I also have this kind of fetish for water cooling, and that's just escalated. So.
It seems like it. It seems like it. That's so amazing. And a quick question for you: how did you kind of first come across Filecoin? Like, what was it that kind of motivated you to mine on Filecoin in the first place?
Yeah, so I did Litecoin back in the days, and I think it was probably the size of the ICO. Like, there is something to this that we need to investigate, figure out, what can it do and so on. And also, I think it's a general idea that, if you can do trusted storage, and in the end, maybe just, not really have cloud like we have it today, using for heating our houses instead of heating, ridiculous nothing, then I think that, that would be much better. And even if you can run it on a mobile phone and use the storage there, then, we're really getting somewhere. So, yeah.
Absolutely. Well, listen, thank you so much again for taking the time to share your experience and your expertise with us. Also, congratulations on being a Filecoin community champion. Thank you so much for helping your fellow miners throughout Space Race. And congratulations on being number 7 on your continental table. Very, very exciting.
Yeah, let's see how it goes.
Awesome. All right. Thank you so much, Benjamin. Okay. Next, our next presenter is Charles Cao, representing the NBFS Canada team, who are currently ranked 2nd on the North American leaderboards. Over to you, Charles.
Yeah. Just share my slides. Yeah. So, yeah. Thanks everyone to give us the opportunity to present our stuff. Yes, we are running a Filecoin cluster mining in Canada, Montreal. So, first of all, I would like to introduce ourselves. Everybody was curious about why we call NBFS. Actually, it's a Nebula AI file system. We were doing the decentralized AI cloud computing in the past days. Our white paper in 2017, we were saying that we would like to have the storage solution based on IPFS, so we can doing the decentralized storage with the AI together. So we are waiting the day when there is a good solution can provide the storage. At the end, we found that Filecoin will be a a very good solution potentially for us. So we jump into the mining industry to find how it works. So we have been working in the project for about 3 years. We get a $1 million funding from Canada government. So it's quite interesting we're going here. And those are the servers currently we're using. We're directly using the servers from HP, high performance computing servers. And we are HP official business partners. So with the P1, we're using the AMD CPU server. Basically is the HP 385 type. And for P2 worker, we're also using HP servers. Basically it's the HP server with the dual core Extron Intel server. But we added one GPU, a 2080 Ti into it. So for the storage server, it's just a normal storage server, micro, super micro, or any types, it will be okay. And Benjamin has already introduced lots of details about how to assembling servers, how to in either those storage plus how to schedule them. So I won't repeat his work. Basically, we have very similar design, except that we didn't split the P2 and the C1, C2. So P2 and C1, C2, we are in the same box with one GPU card, by the way. And then we put everything in a data center. So we are using data center for mining. And we have a data center in Montreal, which is, it can support 30 kilowatts per rack. So basically like with 34 kilowatts, we can have all the servers up to 20 in the same rack. And on the rack server, we have one node server running. We have one miner and about 3 to 4 P1 servers with P2 servers working together. So about that, we added a monitoring scheduler, which can help you monitoring any service downtime, anything like overuse used. We have an anti-spam module because early is the date when we're still the #1 in North America, we get an attack from the traffic. At that time, we build a new anti-spam shield, which can detect malicious behavior and add to the firewall policy to block them. And the scheduler running every day to detect those behavior from script and logs and lots of other things. We have a RESTful service which can enable our team to analyze how much production per day, per hour, and also put it into a scheduler to monitor those service done and something not working. At the end, we have authentication services built on top of the Filecoin infrastructure. So for people who want using a mobile to monitor each of the servers which they want to rent, they can see how it works using the username, password to get a credential to access it. So this is the software architecture we built. And those are the dashboard we are using. By the way, this is not the real dashboard we're currently using now. This is a conception that we used. You can show if you have a multi-geo location, you can see how many servers are running, the traffic flow, and up and down time. This is one screenshot is taken from our production server. So we can see that there was a place, for example, this one, we have 99.99% used. Obviously, this is the P1 worker. It has multi-threads parallel about 16 to 17 parallel processing. So it takes about, so we need to be careful about this one. We need to distribute load to other servers. And we can see that we have the partition used about 80% or 70%. We need to take care. We need to arrive to 90%. It requires certain alerts to our notification and mobile. So our engineer will take a look, release some space, or decide if we need to add an extra hard disk for help. Sorry. And here you can see the throughput per hour, per day. It have about 30 terabytes input and output. So sometimes when it goes too high, means some service inside this one has a problem. Those are the, if we want to check any of the services working, we can check the GPU usage. Usually when we have a GPU usage like this, which means it's healthy, which the pipeline is not broken, it continues doing the job, If they see that big gaps between those spikes, which means that you have too much idle time, you need to check your scheduler to see if there's some stacks. For example, message pool is full, or something like you have lots of P1 jobs idling, or something was stuck somewhere, you don't know, you need to log in and check it. And we have a development environment just for testing. So writing a customized scheduler to grab all the status, so you can see the different color on different server, how many jobs currently running, P1 job, P2 job, and C1 other PCs, and you can see the memory usage, CPUs from another direction. So plus this one, so you can pretty much get every information you need. Yeah. So, but if we have lots of issues during, or we can see challenges during the setup. Due to the COVID-19 in Canada, the supply chain becomes a big problem. It usually takes 2 to 4 weeks from ordering to shipping. And when parts arriving, sometimes you need to customize and upgrade by yourselves, because the HP servers usually have the original design. But if you want to add new pieces, for example, you want more memory, or you want more CPU kit, it's not just expensive, but it takes 1 month or even 2 months shipped to you. But for mining, if you want to catch up with the meetings, the space race, it won't work. So you need to manage this. Hardware testing is another heavy job. We have so many servers, lots of different cables, and lots of components, and some components which was remarkable by the community, something like a NVEM or something like that. You just cannot find it in Canada. It doesn't exist. Either you order it from China or order it from US, but in Canada, just don't have those equipment there. So you need to find some alternative solutions, and you need to just balance them, the trade-off, timing and the cost. So operation is extremely difficult because all the hardware is working under high pressure, almost 100% usage. You might have broken in SSD, you might have broken in network card, and you need to set up lots of monitoring, and you need to, and then the data center is not in charge of maintenance those things. You need to working with it. You need to send the people, schedule the service. You need to have backup parts. So you need to manage your budget to say, okay, we have 100 server running. Now we need to have about 10% backups or 20% backups. Those things is very complicated. You need management. And because the during space race, we didn't expect it that the team will release on daily basis. So originally we are not designed for this. We think that we have one thing set up, and then we can just running after 21 days, everything's done. Well, okay, but actually it's not like that. We basically have every race per day. So we are struggling. Do we need to follow the upgrades, or just waiting a few release, then we're doing upgrade? That will save lots of time and effort. But at the end, I decided to follow the official releases pace. We do upgrade every day, even though we lost about 20% to 30% of the output. But I think it's worth it, because from those things, we found that we can help lots of people. We found a lot of bugs in the day one, and we found a lot of things like people also in content need help. But if you see that, no, I'm sorry, I'm still using 0.5.1, so I cannot answer the question. I don't think that's helpful for the community. So we decide instead of getting high rewards, we decide to find more bugs, help more community members. So in that case, we're doing that one, but it's become challenges. You need to management. So this is some solution we found. So first of all, we're building an ERP system for tracking the inventory and the quotations. For when the quotations comes in from different vendors, we immediately put it in the ERP system, and we manage our equipment inventory to see how many SSD we remaining, how many HDD we remaining, and can we need some quotations for fulfill our inventory. So this is now done almost automatically. We have invoice system, we have quotation system, everything added together. So when there is something happens, there will be trigger alert as us to fulfill the equipment. So automation pipeline is important. We have auto build system on the servers, and it can deliver all the builds to all the servers at the same time, start all the script. When workers offline, there's monitoring service will trigger an agent on each worker to wake up those services to automatically reconnect to the miner. I think miners also aware that your workers occasionally were offline due to whatever reason, disk I/O or just the AC key not received. In any case, we found we have 2 steps of monitoring. The watchdog running on the server and a watchdog monitoring service on remote worker, which is our own work. So basically, we have another distributed system working with the Filecoin distributed system together. It's a little bit complicated. And also, we've been using lots of container-based technology for continuous delivery. So we're building the anti-spam system to monitor those malicious behavior to block those servers. So after that, we didn't suffer the problem of the missed win post or lost raw power due to the attack to the message attack to your miners. And in order to find the best way to manage those hardware, the P1, P2, how to working them together, I wrote a simulator which can accelerate the process using deep learning technology. So you can simulate thousands of times how the workers working with each other and exception handling. Use the software instead of you define one configuration, you put it on running and you spend another 12 hours, then you know that, okay, it works or not. No, we don't do that. We're using deep learning technology to involve those systems, and it works very efficiently. It can self-evolved with the job process. Yeah, and here comes our future plans. So we would like working with China suppliers for lots of important parts and to scale up the mining. And we want to find the partners in China doing the marketing and coal mining in North America, because North America for now is still low in storage compared to China and Asian. So we wanted to working with them together to building another mining location, a bigger mining location in Canada or even in US. So, and we have very good relationship with the local government. We can help them to working with the local government and how to pass the compliance, follow the law and everything locally. We would like to contribute the code for the operating and testing, for example, those anti-spam software, those continuous monitoring software components we want to contribute as soon as it is mature enough for open source. And then we want to working more with other miners in the community. We get lots of help from the community. We get lots of information, and they help us a lot in the early days. And we want to working with them and contribute. Yeah, this is our team. This is me. Well, actually last year I was visiting China. This is our office. Now our people install the servers and developers coding, testing, everything. Yeah, that's pretty much for our staff. Yeah.
Awesome. Thank you so much, Charles. That was really, really interesting. And it's especially, I think, valuable to kind of hear about some of the problems you faced and how you've overcome them, the solutions that you kind of implemented. So that's really, really wonderful. And I know that we've seen a lot of bug reports come in from your team that's really, really helped kind of like improve the system. So thank you so much for that. We've got a couple of questions in the chat for you. Stuart Berman says, very professional NBFS. How much redundancy/resilience does your system have? Yeah,
for now, for our system, we have about 20% of redundancy. Usually, like if we have one P1 worker or two P1 worker offline, other workers will take more jobs. Usually, we reserve 20% of the capability, and This is from software part, and the hardware part, we have components for replacement as well. Usually if the system is down, we need about 6 hours to get it offline and then run online. So the replacement time is about 6 hours, but the service downtime is within 20 minutes.
Wow. Okay, great. Thank you so much. Another question here from Ask Ender. When P2 plus C1 plus C2, will P go to another machine to continue C2? If C2 comes first, will it start C2 first?
Yes, that exactly the problem we are facing now. So that's some people was asking us to rewrite some schedule, customized scheduler so can better arrangement those sequences. And that's something, the next step we want to do after the space race is completed. We would like to write some code to more deeper about the scheduling service. I think Y is working on that. He said he has something is interesting, can reduce the P1 to 119 minutes. So that will be interesting. But I'm still thinking about that because for me, I really don't want to touch this part of code. I think the team can do the best job for that. But if when mainnets are launched and we still don't have that one, our service consider rewrite it.
Awesome. Well, it's like we say, it's like a community effort. So yeah, definitely like always welcome contributions from everybody. Okay, one last question for you, Charles. How are you monitoring infrastructure?
So for infrastructure, we have lots of software working together. Mostly was created by ourselves previously in the cloud computing. So we have the software monitoring the rack, the hardware. So basically, they provide, because they are servers, they have IPMI. So you can read the disk, the temperature, everything, you can read it. And so the data metrics in collection is using Grafana for sure. But for the service jobs, that is another service writing by myself. We're writing a service, we create a database. So we go through all the logs, we're talking using the API, talking to the Lotus API and Lotus Miner API. We gather the real-time information into the instantly to the database. Then we can do the data analysis. We won't take we won't describe it as a big data, but we do really using lots of big data technologies to extract those informations to build in the graphs.
Awesome. Very cool, Charles. Well, listen, thank you so much again for taking the time to share with us today, and very best of luck to you and the team for the rest of the competition.
Thank you, guys.
Okay, our final presenter for today's show and tell is Wondertan, who is competing in the European Continental Board with an impressive 6.56 terabytes in storage added to the network. Wondertan, are you with us?
Yes, I am.
There you are.
Hello.
Hi, perfect. Whenever you're ready, just share your screen.
Sure. So I want, let me start. I'm Hlib Wondertan. I live in Ukraine, and I decided to go into space race for many reasons. I live in Ukraine, and this talk will be much different from what you've seen before. There won't be any kind of special hardware, like a lot of team working on updating the code. This is kind of like just a simple miner who wants to commit some storage for Filecoin and maybe help it to evolve right now, or seeing any future perspective from it, kind of this thing. So I would like to tell you why Filecoin. First of all, I am a developer and I've been in crypto sphere for quite a long time, and I was looking for PL from like the first time I've seen IPFS, and that like their project Filecoin made me like interested, and I wanted to join it anyhow. Then I saw a space race events and decided to join. Like even I had a really short time frame for that, because I wasn't in Ukraine for when I decided to do that, and I had like actually 2 weeks before space race to prepare for them. So those like last month for me was kind of intense to manage all of this. While Filecoin more, I really think that Filecoin has great value for a crypto community and for like technical evolution of humanity at all. It's kind of different. They have really strong economic model, having power, having storage as your stake in the network, provable storage. This is really cool. So like I'm really I'm sure that Filecoin will be really helpful and demanding in future and be very popular crypto project. So I decided to join it. That's kind of well. So the team and investor, that's a mistake. Team and investors, I would like to say here. So the team is only one person, me, who decided to do that, and found some investors for this. I convinced them that this is a really great idea. One of them is my father, and other is my good friend. Also, I put some money on it, and we bought at all like 7 rigs for this. That's kind of like big amount of money for just mining in your basement, I think. But that's all. So about hardware and architecture, getting professional server hardware in Ukraine is an issue. To do this in 2 weeks. So the fast decision was to buy a lot of available hardware and available like AMD processors, like GPUs that are popular in gaming sphere. So I just bought 7 machines that have same specs. They have AMD CPU 3790X. They have GeForce GTX 2080 Ti, 3 terabytes of SSDs. Like that, this is very popular setup that was around on Slack. So I've just decided to use it and to mine. About architecture, so this is architecture I want to show you. This is just a photo of custom-made shells for this. So this is 7 machines, 7 rigs that are interconnected with a 10 gigabyte switch. And that's all. So currently there are just 7 separate miners that are combined in space race, but in future, like before mainnet, I think I will still have time to find like best way to use this hardware efficiently for all the committing steps, not to have any of the hardware just sitting around without work, and combine them in one miner. That would be a very interesting thing to solve. So yeah. Next. So also I would like to tell you about their experience in a space race, because when you start to dive into and try to understand like how everything works and how to set up everything. You have only two options for space race. There's docs, documentations, maybe specs, and Slack. So docs and specs aren't very helpful. They just tell you how to do some basic thing on how to install dependencies maybe and initialize your miner, but nothing more special, because when you dive deeper into sectors, how scheduling works, what are the steps, how this all works, what time it takes for every step to complete, how to improve work distributed in scheduler, what workers to do, how to set up workers, and do you need them. There's a lot of things you need to understand before actually starting to mine. So I've got a lot of nights just reading and finding the answer for my questions in Slack if somebody already asked them, to understand what and how everything works, like take everything by pieces and to somehow like create a whole picture in your mind. Also, as a Go developer, I had got some experience and like just I just read some code because it was the simpler than understanding it, some concepts from Slack. And even there is a lot of misinformation. There are free like 4 parameters in configuration for sealing, like the max deal sectors, all this stuff, and they're really not intuitive from the first sight you see them and how this work, what they're doing, and a lot of people telling different stuff on Slack that are not meshing, and I just decided like, okay, I'll read the code and understand what it does. And that took me much less time to understand and trying to get this from Slack. Like, and I got my hardware like 2 days before the start, so there was a huge rush, and I got many mistakes to actually set up all of this. First of all, like I understood that I can do one miner in my setup, and just to run workers on every machine, and the scheduler will be able to like do the whole work itself. But then I realized that isn't working, and I have no other options just to set up like a miner on every worker. So I've done a lot of mistakes and lost a lot of time to actually gain some more terabytes. And actually, like my current position in Europe would have been higher for the reason I said, like I've lost some time on understanding things, and right now, like I've lost a lot of power through post-submission failures for various reasons. I think you know them on Slack. So my current like power is about like 12 or 13. I think 12 terabytes is it. So yes, and thanks. Like that's all I think I would like to tell you. This is kind of, I think, not usual miner show presentation, but I think that you liked it. So thanks.
No, that was awesome, Hlib. And I think actually Ben, our first speaker, had a kind of similar approach as a kind of independent miner. So it's just great to see like a real variety of approaches to Filecoin mining. And also great to see you moving back up the table again. Like you said, you lost power there for a while, but it seems like and there's still quite a few days to go in the space race. So I'll be excited to kind of watch you as you continue to progress in the competition.
Thanks.
There's a question here from you, from Ben, actually. If you run the servers as 7 individual miners, then why did you set up a 10 gigabit network?
Yeah, this is a good question. I just bought it for, like, originally I thought that they should exchange some data, but that setup just, to be honest, that switch just like sits there without work. And this is for future upgrade where I'll like combine this all into one miner, and the 10 gigabit switch there is a must.
That makes sense. Awesome. Well, listen, thank you so much again, Hlib. I know that you've done.
And I want to tell thanks to Benjamin, who helped me a lot to find out and understand some things. So
that's awesome. I think Benjamin's going to have to win the Community Champion Award again this week. He's really been awesome, and I know that he's super active in the Slack channels, and I know that you've been helping people too, Hlib. So thank you so much. Okay, well, unfortunately, that's the end of the Miner Show and Tell today. I'd like to close the session by saying a huge thank you to our wonderful presenters, Ben, Charles, and Hlib, for sharing their Filecoin mining expertise and experience with us, and to all of you for tuning in. If you'd like to present at the next show and tell, then we'll be posting a sign-up form in the Filecoin Slack shortly. You can also catch up on all of the events that have been taking place throughout Space Race on our YouTube channel, which we'll post in the chat below, and we also link to in the Filecoin Slack. We'll be announcing the next Miner Show and Tell very soon. In the meantime, enjoy the rest of your week and your weekend, and happy mining. Thank you so much. Take care.